Good evening, everyone. My name is Mark Berry. I'm the president of Schoodic Institute at Acadia National Park. It's my pleasure to welcome you this evening and to introduce our talk. And I just want to briefly comment about Schoodic Institute, who we are. We're a nonprofit that works in a very close partnership with the National Park Service here at Acadia and beyond. Our focus is on advancing ecosystem science and learning for all ages. We often work at the intersection of those two things. So we work in citizen science, which engages people in the scientific process, and in connecting science to conservation. And this is a fantastic place to do all of that work. If you are already connected with us or supporting us, thank you. If you're not, but managed to find your way here tonight, we hope we'll see you again. And hope you will use our website as a tool to help you connect, sign up with our newsletter. We have a lot more events coming up this summer, many of which are already on the calendar, others which will continue to be added. But even this week, on Friday, there are 3 things back to back here, so you could come to a noontime brown bag presentation on clean vehicles and alternative transportation, what's available now and what's coming next, from the Maine Clean Cities Coalition that has helped the park with, and the Institute with, some new vehicles that are improving our act and our approach to issues that are relevant to tonight's talk. And then at 1 o'clock in the auditorium here, we are hosting a live broadcast of Maine Public Broadcasting Network's Maine Calling program. So many of you may have heard that on the radio over the years. They will be broadcasting right here a program about Acadia's centennial. Public is welcome and may have the opportunity to call in via microphone and participate that way. And then right after that, Park Service and the Leave No Trace Coalition are hosting a free training and workshop. So we've got a full day Friday afternoon, and then a very exciting day Saturday as well, mostly not here, but Saturday is Park Science Day, and we are one of many partners contributing to that. If you have an opportunity to make it over to MDI, or perhaps even have come from there, the event starts at 1 o'clock at the Sturdamont Nature Center. It will include some presentations and a rededication of the Nature Center, and there are shuttles available from Jackson Labs. You want to do a little bit of advanced planning. There will not be parking at Sturdamont, but it should be a great afternoon. Some exciting announcements there, new exhibits on climate change at the Nature Center, and we'll be talking about some partnerships for science in Acadia. And with that, I sometimes go farther with my schedule, but we've got enough going on this week. I'm going to stop right there. Introduce Christy Anastasia, who is the Deputy Chief of Interpretation for Acadia National Park, and she's actually going to introduce our speaker tonight because she helped to arrange this program for us. Good example of how we're always working together. Christy.
Okay, I see a green light, and I'm going to see if Jim hears me. Yes. As Mark said, my name is Christy Anastasia, and I'm often on the Mount Desert Island side of things, but I get over to Schoodic as often as I can. I was just camping here for 4 days last weekend with both my boys, who spent a lot of time rollerblading in the campground. This winter, the team on Mount Desert Island spent a lot of time thinking about climate change, because we are opening a new exhibit in Sturdamont on climate change. And we thought about, how are we going to talk about climate change? And do we know enough about climate change to even begin to talk about it? While I was sort of struggling with how I was going to train my staff, I was scrolling through my Facebook page, and a friend of mine had posted that his brother-in-law just published a book called Climate Change for Beginners, and it was pure providence that it was there, because it was exactly what I needed at that moment. So I very swiftly ordered as many copies as I could find, gave them to all my interpreters, and then used the powers of the internet to reach out to our speaker tonight, who very graciously accepted the invitation to not only come and speak here at Schoodic Institute, but also to do a private conversation with interpreters last evening in the Halsco Visitor Center. And I am just always amazed at how many friends the Park Service and Acadia and Schoodic Institute have. And I'm just so thankful we have such a beautiful place to attract speakers here. With that, I want to introduce Dean Goodwin, most recently the author of Climate Change for Beginners. Thank you.
Thank you. Well, good evening, ladies and gentlemen, and thank you very much for coming out tonight. I want to thank Christy and Mark, and also Jim in the back there, the tech guy, for helping out tonight, and for the very gracious invitation and introduction. I can safely say that we need institutes like the Schoodic Institute, and we need to continue with the National Park Service and supporting them in any way we can, so that in another 100 years they'll celebrate their bicentennial. As you will see in a moment, it's very important for us to continue to educate the people of today in order for us to have them live in a habitable world of tomorrow. And my daughter, who's with me tonight, when I asked her what she wanted to do today before we came over here, she wanted to go up Cadillac Mountain, and then we went down to Thunder Hole. And I was very impressed with the number of people that are out there looking at nature. When I was growing up in England, I did that a lot. I was out in the woods, just walking around, just being at one with nature. This is a series of woods called Hopworth Woods, where Henry camped his troops before the Battle of Bosworth, where Richard III was defeated. I would spend many hours either walking around there, canoeing and camping on the canals that were there. And you may have all be familiar with Richard Lowe's book, The Last Child in the Woods. And this is what I've tried to overcome with the young people today, this nature deficit disorder. It made me feel, it warmed my heart to see so many out there today up in this beautiful part of the country. Tell you a little bit about myself. I obviously come from England. In 1976, when I was doing my degree, I came over to the States on an exchange program to work at a summer camp. That summer camp was in Maine, down near Colby College, near Waterville. I came back every year to spend my summer at the camp, in the outdoors, working with young kids, to hopefully instill in them that passion and desire that I had to do things and work outside and appreciate nature. In 1986, I worked there till 1990, every summer. In 1986, I came over here full-time to live, and I've been teaching. I came over from teaching at a university to teaching at the high school in the States, worked down in Virginia, up in New Hampshire for 13 years, and right now I'm in Wilmington, Delaware, at the Tatnall School. The reason I chose the Tatnall School to work at, when I was looking for, as we all do sometimes, look and say, is there anything else I can do? Where can I do it? And the Tatnall School's motto, I don't know if any of you are Latin scholars, omnia in caritate, it means all things in love. And what we do there, it's a pre-K through 12th grade school. And what we do there, we instill a love of nature in the children that we work with at every level. And I've not come across a school that had a similar passion that I did for nature as they do. And, it's a real thrill and honor for me to work with some of these people that have been doing this for over 30 years at that school. So when I was looking around, I was in Virginia wanting to move a little bit further north. My wife's from Boston. I met her at Maine in the summer camp. So I have a very large affiliation for Maine, and also My daughter goes to summer camp in Maine. She's off there on Thursday, and she'll be back up here with her group, with her age group, to camp out and hike Cadillac Mountain again, and things like that. And my son, I think I might have done a good job in passing on that passion to him, because right now he's working with one of my colleagues at my school. We have summer programs, and he's working with on a nature program for little kids this week. So, that's sort of my, goal. Because of this. And we are combating this with our young children today, more and more, and even some of us. And there's so much to distract us. Facebook and Twitter and, all of our iPhones, gaming, even now the new wristwatch thing that I don't bother with, but it's caused what I call social interactive disorder, and we've taken ourselves out of the interaction with nature and put ourselves into an interaction with the technical world, some of which is good. I'm not trying to say it's not, but I know for myself, having two adolescents, that and you may have no children yourself, that it's hard to get them sometimes off the computer and go out into the world outside. So I'm very happy that when we were in New Hampshire and it snowed, my kids and me will be outside on the hammock, which I left up all year, like catching snowballs on our snowballs, or lying there on the hammock and letting the snow get onto us and just appreciating it no matter what the season is. I have done some work with the College Board to teach some teachers in the New York State Department of Education about these topics, because it seems that there's a lot of misinformation about topics such as these. And the first one I did, a course for them, was on this air-sea-land interaction and how that affects climate change. And the recent one I've done is this climate change causes and consequences. So I'm not only involved in day-to-day teaching students, but also have the opportunity to teach adults about this too. So why is global warming such a hot topic? I believe this. I totally believe that, the IPCC has got evidence that is overwhelming. But there is a spread of misinformation, all the time in the media. And it tries to give the wrong impression to the public. And there's a lot of confusion that leads them to misunderstanding of the science. And as a scientist, we base our judgment on observable, data that we collect and analyze. Sometimes we change it when we find new data that comes along, but that's one of the beauties of science. So I believe this, that we are doing and I call it enhanced global warming. I'll tell you about why in a minute. It's because of us, and we all play a role in it. Primarily from burning more gas, more fossil fuels, and we need to look at ways to reduce that, reduce the level of CO2 and other greenhouse gases to slow this down. That's some of the goals. And that's hard sometimes because there's so many of these untruths around and so many junk science facts that we have to combat as a science teacher and as a scientist. Special interest groups are continuing, even now, to put money into evidence or setting up organizations or funding organizations that say that climate change is still a myth. And they are doing that primarily because they are worried about some of the regulations that may come down the pipe when we try to control the emission of greenhouse gases. Even though economists have studied this and said If we can control CO2 emissions and other greenhouse gases, it'll actually generate revenue. The economy will not suffer, it'll be enhanced. And the problem is that this misinformation is really what gets put out a lot in the media, in magazines and also on the TV. And so you've got people like this saying stuff like that. And of course, I wanted to show you that person. Here he is.
Of national attention, and in case we have forgotten, because we keep hearing that 2014 has been the warmest year on record, I asked the chair, you know what this is? It's a snowball, and that's just from outside here. So it's very, very cold out, very unseasonal. So here, Mr. President, catch this.
Some of you may remember that when Senator Imhoff decided to disprove climate change by finding a snowball in Washington during winter and taking it in and throwing it at the President of the Senate. To me, that didn't disprove anything. It just proved something I'd already thought of all along, which I will not tell you. And you can probably guess what that is. Because some of these people don't understand the connections, and at that time, you know, when we had that very severe winter, a little bit abnormal in certain areas along the mid-Atlantic seaboard, well, I tell my students the Earth is a system of lots of interconnected things going on all the time. And that year, the jet stream was forced further down, bringing a lot of cold air further down the eastern seaboard than normal. And also the Alberta Clipper was lower down as well. And that was partly due to a word that came into our vocabulary at that time, the polar vortex, which again, that can be linked to changing climate over the Arctic. So these people are not really looking at all of the incidences of what's going on. You know? For example, like El Nino this year has been one of the most, the highest differentiation between the sea temperature. It's the biggest differentiation for an El Nino ever. It's the strongest El Nino ever recorded. What you're going to see up in Maine as a result of that, and up in this part of the world, is you're going to have a milder winter as a result. Because El Nino affects the climate. Of course, that's what would happen if it was just El Nino causing climate change, but we don't know what the polar vortex is going to do and how the jet streams are going to go. So I wish some of these people would really look at the science. The PBS did give these people that were doubters an opportunity to express themselves in a show a couple of years ago, and it was called Climate of Doubt. In that presentation, science wasn't mentioned. It was just people that were saying, oh, you just don't believe it. Well, these scientists are saying this, the climatologists are saying this, well, I don't believe them. You know, and it makes me think that, you know, right now there's 97%, I've heard in some things I've read recently, that it could be up to 99% of all climatologists that work in the area of climate change really think, you know, that they're on board with it. And, you know, to me, I was thinking, well, I wonder if one of these doubters had some disease that needed an operation, otherwise they might die. And they went to 100 doctors, and 97 of them said, yeah, you've got to have that operation. And 3 of them said, oh no, just walk extra a bit every day or something. It's like them believing the people that say, no, you're going to be okay, as opposed to the majority. You know, so I think that, and I've said to some people I've come across, I said, look, well, let's say that you're right. Let's use the precautionary principle. Let's actually do something about it, just in case the scientists are right. You know? And then if you are wrong, you can feel all smug about it. So you're going to be okay. So I come from this, I wanted to put that out right up front, you know, that I come from the point of view of it's happening, it's real, and, you know, I've heard enough from the doubters over the years since I've been teaching environmental education since the late 80s. In fact, a few years ago, some of my students said to me, "Oh, Doc, are you going to go to see the meeting tonight down at the town hall?" And I said, "What is it about?" "Oh, it's called The Myth of Global Warming." I said, "No, I'm not." They said, "Why not? You can tell them it's right. You know, you can tell them that they're wrong." I said, "Well, first of all, I know it's not a myth. You know from the research that you've done in my class, it's not a myth. And if people go into that or think it's a myth, it's a waste of my time. You know, because they don't want to listen. It doesn't matter what you put in front of them. It's still, they're not going to believe it." And one of the kids said to me, "Oh, it's like trying to teach a pig to sing, you know." And he's like, I said, "Why is that?" He says, "Well, it annoys the pig and it frustrates you because you're never going to do it, you know, something like that, some crazy thing." So so they understood why I wasn't going to go. But so we're all about, you know, these skeptics. I wanted to put this up because this was said in 2007 by the executive secretary of the UN at the Bali conference. You know, so I tend to go with that. This is what was said by the United Nations Secretary General about climate change. I'm not going to stand here and read this because I know you all can read, and I try to tell my students when they're doing PowerPoints, if you put a slide up that has words on it, don't stand there and read it, because that's death by PowerPoint. Your audience can read, so, you know, so I'll just put some up and you can have a look at them. So let's put some things into perspective from an historical point of view. Yes, the Earth does have changes in the climate, some of which are pretty dramatic. And we do have hot and cold anomalies. I know none of you here will remember this, but in New England, it snowed every month, even in June. And I don't remember this, but in Europe, we had the little ice age. Sometimes these are used as facts as, oh, see, you know, this is what's going to happen. You can't predict anything. But this guy did. And when I was researching for the book originally, the first time that the book was published was in 2007, 2008. I tried to find out, when did somebody link climate to effects on the Earth? And it was this guy, George Perkins Marsh, who was a farmer up in Vermont. His views were impacted by views coming from a guy. Last night when I was at the Park Service, I mentioned about a guy called Humboldt, who's a German, and you might have heard of the Humboldt current. His work, he was like the first naturalist. There's a book out by Andrea Wolf called The Invention of Nature, which talks all about this guy. And he influenced this gentleman. He was a great friend of President Jefferson. He actually gave Jefferson facts about his travels, which led to the Louisiana Purchase. He influenced the thoughts of Thoreau. He influenced the thoughts of John Muir. And Darwin took one of Humboldt's books about nature on his voyage on the Beagle. And the book is actually in the Cambridge University Library, and you can see Darwin's annotated notes in the book. So these were people that in my research I didn't sort of come across as having anything to do with climate change, but Humboldt was the first person to actually go as a naturalist and look at and try to catalogue lots of different plants and animals in different parts of the world. And he kept immaculate and intricate notes, which these people, and he published them, and these people read them, and it really had a profound effect on the people going forward and how we think about nature and the natural world. Well, George Perkins Marsh, again, who was a Humboldt fan, he was kind of, Humboldt, I would say, he's like the rock star of the 1800s, of the early 1800s, kind of like Neil deGrasse Tyson is today, and maybe Bill Nye. This is what he said in 1847. And that's the first thing I could find about anybody linking climate and the earth and us. This is very pertinent to me. It's by David Sobel, who works down at Antioch College, who's a really big proponent of place-based education. And because I work with young people, I can relate to that. Some of you may be familiar with David's work. He's a great guy. And so, from my point of view, how do I get, because the future is the children I'm teaching. And so how do I get them to get off that computer, put that game away for an hour or two, and get out into nature? Well, the kids of today learn differently than what you did and what I did. And I have to take that into consideration. Years ago, we were in an agrarian society, and we learned how to work the farms. Then with the Industrial Revolution, we're having schools that were making people ready to go and work in a factory. Then come along the era sort of in the 20th century, which was content-driven education. Learn something, memorize it for a test, and get an A. Today, it's a totally different ballgame. Students of today are going out into a world where it's not necessarily the content that's going to matter to them, it's how they can put it together, how they can fit the pieces of a jigsaw together in a totally different way than has ever been done before. And there's a load of stuff out there on 21st century skills and what that means for the students of today and how we need to change education in order to have them come into the world of tomorrow. You might have heard of this. STEM. It was even mentioned in State of the Union addresses. You may have heard of this, because now art is being stuck in there. Of its STEAM. I'm right now in the process of taking that a step further. What do you think it might be here? STEM, STEAM, streams. Thank you. Yes. Streams. So I'm working on an article about turning STEM into streams. So what do I mean by that? What's this crazy teacher thinking? Well, we have the science and the technology, but we have R, research, and then the engineering, the arts, and then S. And at first I said society, but I've now changed that into sustainability. So turning STEM into streams is where I come from in that movement, and it's in order to try to get the students that I'm dealing with and sharing my knowledge, and I don't pretend to be the expert at all on anything climate change-wise, but I've studied it for a long time. I believe in the science behind it, and I want to pass that knowledge on to, whether it be the adults who are teaching the kids, or to the students themselves, so we can protect this beautiful blue ball that's meandering around in our universe. So how do I do that? I attempt to do it by taking them out into the field. This is a group of students that are looking at oyster beds in Virginia, on the Chesapeake Bay, getting them to record and do research on the water conditions, which, like up here, the water conditions are changing. This is a group of students I took out to an island in the Chesapeake Bay called Tangier Island. And we go there for a couple of days, and they do a lot of intensive research, not just about the actual science that's going on in the island, but also about the socioeconomic things that are going on there. They interview the fishermen. We go, and we were on our way that day, actually, we were on our way to visit with a family that have lived on the island for several hundred years, their family has, to talk to them about it, so they can actually get authentic knowledge. It's not rained. Sorry. That's right there. Here. This isn't a puddle from the rain. It's a puddle from the rising tide. Now, on that island, we walked about 10 minutes across the island, and we stayed for about an hour, talked to this family, an hour and a half. On the way back, the water level had gone over the path, over the road. We had to take off our shoes and socks, and it was probably about a foot high. That's what that island is experiencing on a daily basis as a result of climate change, as a result of sea level rise. So I want to, in order for me to, it's no use me just telling the kids this. I want to take them out and let them experience it. There's some of our students out at Tatnall looking at doing some stream studies. Here are some of the younger kids. I mentioned how we go through, pre-K right through 12 doing this. This is a program that I started when I was in New Hampshire. A friend of mine, who is a sixth-generation fisherman out of Booth Bay Harbor, his son was at my school, and he came over one time, and we were talking about fishing and overfishing, and he said to me after the class, he said, you're the only person that I've come across who's teaching about environmental stuff that don't just sit there and knock the fishermen on the heads and say it's their fault all the time. Because I was trying to give a balanced view of what was going on. And so what we started doing, I would go down to his boat in Portland, and we would take students out, and they would learn what it's like to be a fisherman, and on research studies. And then he would come to my class and talk to the kids about it. He was working at the time on a program with UNH, and he was at a meeting there one day, and he told them about what we were doing, and MIT, UNH, Woods Hole linked with us to form this thing which I called Adopt a Boat, where we have students across New England linked up with fishermen off the coast of Maine and Massachusetts. We had a school in Vermont linked with a lobsterman out of Monhegan Island, and he went out to the school in Vermont, and they went out and spent overnight and learned all about lobstering. It was a really excellent way to get the kids to understand what's going on. And they can talk to them about, what's happening to the fish? What are you learning? What should we be doing? This was the trip that I got these photographs from. We were out with the Gulf of Maine Aquarium, and they were doing research on DNA in herring. This young man is a marine biologist down in Florida, and this young man works for the environmental department in Hawaii on all of their recycling and instituting new recycling programs. This guy I wanted to put up, he came with us. He's a great guy. His name was Stephen Sotloff. We all had to go through and put this suit on as a safety drill. And he ate the most lobsters that night, so we called him the Lobster Man. I always, when I'm doing something like this, put Stephen up because Stephen, unfortunately, was the second American journalist to be beheaded by ISIS. So his memory lives on every time I do a program like this. And there's to you, Stephen. You're a great young man. And again, this is how I get my students to brainstorm. Ask them questions you have to think about. Brainstorming is not new, but getting them to do it, working cooperatively. here I've got, this is my 9th grade biology class this year. I asked them to design an experiment. And they're putting up their design diagram on the board. You know, I kind of like this picture because it's, you know, the littlest to the biggest, and they're all taking little bits on the board. Real good cooperation and teamwork. That's actually my daughter there, who's at the back. But I think that's a pretty cool photo. So I wanted to give you a little bit of background about me and about what I do as an educator. So, again, where do we go from here? It's definitely got to be something that governments buy into, and it ultimately depends on all of us to become well-informed citizens about what's going on with the climate. And just like we want to have people scientifically literate, environmentally literate, we also need to have people that are climate science literate. And so if you can look at these 4 things and check them off, you're well on the way to becoming a climate science literate person. You know, you need to be able to understand the system, which is what I started out with. It's a system. We're not isolated things, it's a system. And you need to know how to assess some of this information. And I've said that credible information. None of your junk stuff, credible stuff. And then communicate it in a meaningful way. And then, this is the kicker. You're making, as a citizen of the 21st century, you're making informed and responsible decisions. And you hope that your elected representatives will do the same. So that brings me to the book that Christy mentioned. I was first asked to write a book. It was called Global Warming for Beginners, and it was around 2007, 2008. And I was recommended to write it because the publishers were looking for somebody that they felt could take a complex subject and write about it and explain it in a fairly non-biased way, but was accessible to people that were not scientists. So this book, it's not, it's not a sort of a big scientific journal, but it's something that can be read by people that don't understand science very well, but hopefully when they've read it, they will get a more understanding of the ins and outs of what's going on from the point of view of systems. Last year I was asked to update it, which I did, and we called it Climate Change for Beginners, which is great because that's what I would have hoped the title to have been in the first place. But at that time, global warming was the buzzword. Now climate change is. So that's kind of cool. And so, this was published in March with all of the updated facts. And it's being used, I think I attained the goal of it being accessible by many because I've heard that middle school teachers are using it in their classes, high school teachers have used it in their classes, and I know of at least one intro climate change course in college that's used it. So, and I'll have a few copies if anybody wants them outside afterwards. Got a few with me. So that's what I was asked to do in an attempt to promote this passion and knowledge that I've acquired about climate change. So we all hear about CO2. So where did CO2 get the blame? And again, a little bit of a historical perspective. This guy, John Tyndall, president of the Royal Institution in Great Britain, he was the first person to find out that, hey, look, CO2, carbon dioxide, absorbs heat. This French guy, Fourier, he talked about the atmosphere behaving like the glass of a hothouse. From that, we get the greenhouse effect. And then this guy, it blew me away when I was doing this research initially, back in 2006 and 2007. But this Swedish gentleman, he actually said, hey, all of this CO2 we're kicking out from the Industrial Revolution, it's going to result in the temperature of the planet getting warmer. And he actually made calculations of the anthropogenic or the human-induced causes and increases and he made predictions. I mean, that's going back to 1894. And of course, then about 50, 60 years later, this gentleman who measured the CO2 levels above the mountains in Hawaii started to get the data, and initially was a little confused by it because it kept on creeping up year after year. And some people feel that this data set is probably one of the most important scientific data sets of the 20th century. And I will refer back to him later on. So I didn't want you to think that it's all CO2 that's the bad boy in this game. It's not. Methane, nitrous oxides, and chlorofluorocarbons all have a role to play. The reason I put this slide up is that if you look at the effect of the warming, how much the CO2 can, absorb the heat, if we give that a value of 1, then methane is between 25 to 28 times better at absorbing heat than CO2. Nitrous oxides that are in the atmosphere are over 300 times better at absorbing heat than CO2. And chlorofluorocarbons, they've had, depending on which one it is, they've got capacity to absorb anywhere between just under 1,000 to over 10,000 times the heat that CO2 does when it's in the atmosphere. But CO2 is the one that we all hear about the most because that's the one that we are kicking out the most, and it's also the one that has the highest parts per million, even though these are lower, but they have a greater warming potential. So some of these compounds that get into the atmosphere, some of these greenhouse gases do come from natural sources. CO2 from volcanic activity, methane production from swamps and methane hydrates in the ocean, and also nitrous oxides from lightning strikes. But these are the anthropogenic human sources. Obviously, you all know about fossil fuel. We kick out a lot of stuff from agriculture. Deforestation diminishes the amount of CO2 that can be taken from the atmosphere. Landfills kick out a lot of methane, and industrial chemicals, like CFCs that we've now banned, but there are other industrial chemicals that have a similar effect. I'm reading a lot about the flatulence of cattle, the methane production that comes out of the burping and farting of cows and other domesticated livestock. Because we're eating more meat globally, it's not just cows, but it's any livestock. I've read in some articles that it's been estimated that the amount of methane coming out of these animals could be on a par with, or maybe even higher, of an effect on global warming than CO2 from the emission of tailpipes. I don't know how true that is, but I'm seeing things like that coming out about it. So I hope you all understand what a greenhouse gas is. Once it's in the atmosphere, it can absorb the gas, absorb the heat. There's the sun, warms the earth, and then that heat gets reflected back out into space. Well, we do have some greenhouse gases in the atmosphere. Water vapor is one. Carbon dioxide is another, at low concentrations. Methane is there as well. And some people have told me, the greenhouse effect's very bad. Global warming is very bad. I'm like, well, not really. Because if we didn't have these greenhouse gases, the temperature of the Earth would decrease to a point every night where life would not have been able to exist or evolve on this planet. So we do need some of these gases in the atmosphere, and it's because we have them that we've had life on this planet. The problem, and I call it enhanced greenhouse effect, which I think is the right way to depict the bad side of it, is that we are putting too much of these gases into the atmosphere. So it's like at night, in a Maine winter. It's cold, you put a blanket on your bed. Keep you warm. It might get a little bit colder, you might want to put another one on, keep you warm. But you wouldn't keep piling blankets on your bed until you were just lying there sweating like crazy and not being able to sleep. That's what we're doing, I think, to the Earth. We're putting more blankets around the Earth. And what we need to do is to learn how to take some of these off, so we don't want it to warm up too much. So that's a sort of I always like to try and keep things simple when I'm talking to my classes, and they can relate to that idea. That is an amazing thing. I found this about a month ago. I've never seen the temperature increases expressed this way before. Usually you see them in a graph and it goes along and then whoosh, you know. Whereas this, 1.5 degrees C is really one of the, look at the difference there. Amazing. If it gets to 2, some people think that's the point of no return. And we thought 2014 was the hottest year. 2015 blew doors on 2014. 2016 is breaking all records. January, February, March. The glaciers that are melting in Greenland have started to melt a month before they normally do. And I thought this is a pretty powerful way to show how the temperature has increased monthly up until then. And that last line there shows how it's getting further and further. The increases are increasing. So, climate change, I wanted to make sure that this is where I come from in talking about it, and these 3 different ways because a lot of people get mixed up. This is what global warming is. It's when you increase that temperature of a particular area. You have changes in the temperature. It's getting warmer. And you're looking at the air and the seas and the oceans and also the land. And global warming can then result in heat waves. Been on the news today. I heard about what's happening over on the West Coast. Record highs in some places. The fires are occurring again in California. Or you may get some cold periods, depending on where you are in the location of the planet, and depending on what other systems are interacting with each other. Now, global climate change, this is where you have a difference in the weather and the climate. The weather is what's happening over the next week or so, or next month. Whereas climate is what occurs over several decades. And a lot of people sometimes get mixed up with what the definition of weather and climate is. But we are definitely seeing changes in climate when we go back over several decades into the past and see how that climate of the region has changed. And some places will get more rain or more precipitation. Some, the temperature is going to increase. Increased intensity of storms, and we're going to see circulation of the oceans alter. And again, I want to make sure some of this could be natural from volcanoes and stuff, but mostly it is anthropogenic. So that results in global changes, and here's just a list you can look through of the types of things that, global warming can bring about global climate change, which then results in these global changes. Sea levels I've already alluded to. Biodiversity loss and changes in the cycles. Now, polar bear is doing what indicators do we have that something is going on, something's changing? The polar bear has become the sort of the pin-up boy for climate change. And in fact, it's on the cover of the book. And it is. It was the first, species to be designated as threatened as a result of climate change. There are other species that we can use as indicators for changing. The golden toad down in Costa Rica, it's not been seen for a while. They know that it is prevalent to a certain disease, but also the scientists down there, and I've been down to Costa Rica a couple of times, the scientists down there are really convinced now that it's not just this disease, but it is actually changes in the climate. Because the elevations are where they are, some parts of the elevations are getting drier, and they haven't got places to spawn. The mountain pine beetle, which is up in the Pacific Northwest and up into Canada and Colorado, the mountain pine beetle, the winters are getting warmer, there's more of them, and they're doing damage. This is hot off the press. Last Friday, I saw this, because I'm always trying to keep up to date with what's going on in the world of climate change. This was reported last week. I saw it on Friday. I think it was reported maybe come out a couple of days earlier. This is the first mammal on the planet to become extinct as a direct result of climate change. It's only found on a small island in the Great Barrier Reef. Sea level rise has now eliminated the habitat that's required for that bramble key melomis. I don't know if that's how the Australians pronounce it. That is it. Shame. Last week. Another indicator. Well, in order for you to understand climate change as a result of, with regards to carbon dioxide, you have to have an understanding of the carbon cycle. And, combustion kicks out CO2, but decomposition of plants kick it out. Also, microorganisms in the soil, respiration of animals and plants. So there's a lot of inputs into it. And then it gets taken out, obviously, by photosynthesis. It also gets taken out into the water, into the oceans. Sediments in the soil eventually can turn into coal, oil, natural gas. And if you look at these figures, 750 gigatons in the atmosphere. But look how much is dissolved in water, 38,000 gigatons in the atmosphere, in the oceans. So you have to understand the operation of this, I think, to fully understand the impact of CO2. And when I talk to my students, and it's very difficult when you're talking about billions of tons of CO2 being emitted into the atmosphere. I can't visualize what that is. So in order for me to give them a better understanding, I say to them, okay, 1 gallon of gasoline, it will emit about 10 pounds of CO2 when you burn it in your car. 1 pound of CO2 has the volume of approximately half a refrigerator. You can work that out. It's very simple math from the science point of view. So, I say to them, right, every gallon of gas that you burn in your car, you have the potential to leave 10 refrigerators of carbon dioxide alongside the road. They can visualize that. That goes for every one of us. Every time we fill up, I filled up today, got 10 gallons of gas in my car. But for every gallon of gas that we use in our cars, depending on every time we burn a gallon of gas, we get 10 refrigerators in volume of CO2. Now, depending on your miles per gallon, can reduce the amount of refrigerators of CO2. So, and I get them to work this out, and they look up what their cars are, what their family cars are, and how much. This is based on driving 12,500 miles a year. And because that was a few years ago, that was the average. And I've just kept that value in because it's easy to work with. But if you've got a car that does 5 miles per gallon, you're going to leave 2 refrigerators of CO2 every mile. 200 if you drive 100 miles, and 25,000 a year. Whereas if you're driving a more fuel-efficient car down here, you're still going to leave some, but it's going to be a lot less than up there. And they can relate to that. I also have another thing I get them to do where they work out the amount of electricity they use in their house, and we say, okay, well, if it's from coal-burning power plant, how many refrigerators of CO2 are your family leaving out on your doorstep every month? Where do we find some of the information that we've got? Well, most of it, not all of it, but a lot of it comes from samples taken from ice cores, several miles down sometimes in the Greenland or Antarctic glaciers. And this is what they found out in the past. It fluctuates, that CO2 level fluctuates around a norm, the same with the methane concentration and the same with the nitrous oxide concentrations. One of the things to note up here and this goes back 800,000 years. 800,000 years. And the CO2 level has never gone above 300 parts per million. In fact, at the beginning of the Industrial Revolution, it was around 280 parts per million. Today, it's over 400, and it's not getting any less. You have probably all seen that famous graph about how temperature, in blue, totally sort of matches this CO2 changes, which are in red. And someone say, oh, well, how do you know the temperature was back then? Well, the amount of deuterium that's present in some of these ice cores is related to the temperature of the atmosphere, and they can figure it out. Scientists better than me can figure that out. Here's the Keeling curve. Just before 1960, 58, Charles David Keeling started measuring it. That's what we see. This fluctuation is a result of seasonal changes due to photosynthesis. And here it is, on a monthly basis, month to month, over the past few years. And said, we've hit 400, yes we have, and we're hitting it regularly, and we now are there. Now, we also use climate models in order to predict what we think could happen in the future. And obviously, high-level math, supercomputers are needed. They do show these interactions between energy, air, water, and also between the ocean, the land, and the sea. But the climate models, when you're looking at the rate at which the glaciers were predicted to melt, the climate models don't even come close to the actuality of what is happening. The glaciers, both in Greenland and in the Antarctic, are melting faster than the climate models have predicted. And I don't know if any of you have seen the movie Chasing Ice, but if you haven't, I would suggest you look at it. It's on Netflix. That is phenomenal to show how these glaciers have retreated. So we use these supercomputers. And the other thing that I try and get my students to understand, as I mentioned early on, the Earth's a system, and everything's linked to it. We have these loops. And to let me give you, hopefully an easy to understand thing about what I mean by a system. It's like if this is a classic one, you talk about, the level of water in a bathtub. And that's like the system flow. And so all of these systems have inputs. So here you could turn on the tap, pour water in, and they have an output. You could pull the plug, or you could use a bucket to remove the water. And most of the time, the systems that we deal with have been in a steady state. Okay? Think of a couple of systems that you might know of. One is homeostasis, which is the system that's in our bodies that keeps our temperature a nice, even keel. If we start to get hot, things kick in to reduce the temperature. If we get cold, things kick in to try and help get our body temperature up again. Think of the thermostat in your house. You have it set for, let's say, 70 degrees. If the temperature goes above 70, it'll kick in, the AC will come on to drop it back down. If it goes down below 70, the heat will come on to get it back up. That's a system. Simple systems. We have very complex systems going on in the planet. Now the climate models are actually taking into account these types of issues that we are seeing because we have these inputs and outputs in the system. This is the water cycle. And there's the flow, if you like, the water in the atmosphere, you know. And we have what we call positive and negative feedbacks. Oops, sorry. I've set my timer, so I just wanted to just tell me how long I've been going for. Don't want to keep you all night. This is a positive feedback loop, and you can also have negative feedback loops. So if we look at the level of atmospheric water vapor, if the temperature in the water, you know, the water temperatures heat up, warm up, they're going to increase evaporation. So if you increase evaporation, you've got more water vapor, and that's going to trap more heat. And then you're going to have an increased global temperature. And that's this spiraling out of control. What I try to get the kids when I'm talking to them about it, they're like, positive means good. I was like, not in this case. You know, that's the hardest thing to get them out, to get over to. Positive feedback loops are not good. Negative feedback loops are. So if you have, you know, a certain level of atmospheric water vapor, and then it gets to form clouds, so now some of the sun get reflected to space, the less energy heats the earth and warms it, decrease global temperature, and it'll decrease the amount of atmospheric water vapor. Okay? And you can also see these systems in the carbon cycle. There's a system flow, the atmospheric carbon dioxide level, output, and then the inputs, output in photosynthesis and into the oceans, etc., and the inputs from factories, but also from decomposition and other things. And again, these numbers are gigatons here of carbon. And an example of a positive feedback from the carbon cycle is as the temperature increases, permafrost can melt. And when permafrost melts, it can release a lot of methane because of the decomposition that's undergone in that soil for a long, long time. And then if you release methane, it's a greenhouse gas. The temperature will increase, and you get that vicious cycle. So that's an example of a positive feedback loop. We know that this is happening. This is the normal extent of the Arctic surface ice in September. This is what it was, the lowest that it went to in September 2012. We know that's happening. Here is Greenland, the glacial coverage in Greenland from 1992 to 2002, over a 10-year period. This is the Muir-and-Riggs Glacier in 1941 up in Alaska, and here it is in 2004. And I mean, you can't refute this. I mean, it's real. It's there. And as a result of these glaciers melting, we're seeing increased sea levels. They are increasing, both due to the thermal expansion of water and also loss of the land-based ice. What you need to know is that the Arctic ice sheet, when that melts, it's not having a major impact on sea level. It's when the glaciers melt that can have a major impact on sea level. Think of it like this. If you put a glass of water, you know, in your freezer, you know, say 3/4 full, and you mark where it is, and you let it freeze, or a plastic container so it don't break, And then you bring it back out. You know, you can mark what it's gone to on the freeze level. Bring it back out, let it melt, go back to being liquid water. There's hardly any difference. But if you take a glass of water, half full, and you take an ice cube and put it in and let it melt, and then take another ice cube, like a glacier melting, put it in, the glass of water represents the ocean, the ice represents the melting glacier. Eventually, that water in the glass is going to overflow. That's what is really worrying in terms of sea level rise, because the glaciers are melting even faster than ever before. And they're really worried about the data that they got from Greenland in February and March this year. That was, that the glacial melt season is at least 4 to 6 weeks early at the moment. These are some of the changes then, the global changes that we are seeing and you might see around coastal wetlands can be affected, loss of biodiversity. Coral reefs, very important. Coral reefs, actually, about a quarter of the fish in the oceans use coral reefs at some point. The tundra is melting, the permafrost, I've mentioned that. These polar seas, as the influx of fresh water from the glaciers in Greenland gets into that sea, into the North Atlantic Ocean, it's going to change the salinity and could alter the phytoplankton levels or the plankton levels, and that is the base of the food chain from that part of the marine ecosystem. And higher elevation mountains. Some areas, some peoples are dependent on the water from the spring snowmelt. Some ecosystems are. And if we are seeing in some areas that there's less snowcap cover, then there's going to be less water, and that can have an effect on the mountain ranges. And some people have said to me, Dean, if you want to go and see Mount Kilimanjaro with an ice cap on it, you better go pretty quick because it's melting faster than ever. We're also seeing diseases, emerging diseases, becoming more prevalent. Up in Acadia, the tick is on a resurgence. In fact, throughout Maine, the tick is becoming more prevalent as the winters have been milder, and you're having more cases of tick disease incidents. The oceans are becoming more acidic. Carbon dioxide in the water, in the ocean, forms carbonic acid, and then that can release hydrogen ions, causing the acidity to change. And it also removes the carbonate ions for the utilization of that substance in shellfish or even in the bones of fish. What you're going to see in New England as a result of climate change, the forests will move from what they are currently now, this sort of maple, beech, birch mix, into the future, in our kids and their kids' lifetimes, into a oak hickory or an oak pine distribution. So that's what's being predicted as the warming occurs. That's the surface air temperature graph. You can see how it's increasing, and it is predicted to continue to go up. This is the sea surface temperature change. And sea surface temperatures have all increased. This you can Google from NASA, and there's a nice animation that takes you through the temperature of the land from 1885 up to about 2009. But the one I wanted to show you, and there's a reason for me to show you this one, is here, and I'm going to speed up a bit on it to about, where are we? Yeah, it's about there. The reason I've shown you this is that this was produced by an organization that started out as climate skeptics. But the people they had working with them actually, when they were looking at the land surface temperatures, and this data is readily accessible from places like NASA or NOAA, they changed their tune, which was kind of cool, I thought. And you can see as we get closer and closer to 2009, you're going to see more of this temperature anomaly, which means it's getting warmer. And when this finishes off, you'll see just how much of the planet is actually being shown to have increased the temperature. Again, this is all data that we've obtained from people that their job is to monitor the surface of the land. And you can see what's happening around the place. There are things we can do. Unfortunately, climate change has become political in the last, well, for a while, which is unfortunate because, it should cross the aisles. The only thing I think that may be contentious are these two things. What we're going to do with carbon taxes or cap and trade. There can be argument about that. Economists think that this will work. Sequestering it, pumping the excess CO2 underground, or ocean fertilization with iron, I don't think that's going to take off at all. It's been tested on a very small scale, but we don't want to dump loads of iron in the water. One I did find was this gas field in Norway. It's the only carbon sequestration project that I could find that was working. And they take the CO2, the gas that they get from under the ocean, and they pump it down into this rock formation about 1,100 meters under the sea. And when it comes back up, it's decreased its carbon dioxide content from anywhere from 10 down to 2%. And that's the only thing I could find that was actually an example of carbon sequestration using that. On the way up here, I was listening to the radio a little bit, and this come up on the news that it was on the 20th of June. University of Arizona, it said that they've developed some putty-like substance, and it absorbs CO2 better than trees do. So when it's dry, it absorbs it, and so when it gets moist, it can release it. So it's like, we could capture a lot. They were even talking about making fake trees and putting them outside. So it's quite bizarre, but if it works to drop down the level of CO2, that's cool. But they said what we could do is we could then take it and put these things into a greenhouse and make them moist and have more CO2 in the greenhouse for aiding the plant growth. So that's something that's hot off the research press this week. And there's lots of solutions. Lots of different strategies that you can see down here. And some places are doing this already, or some of these. The impact we'll see in the future. But this is where I'm at with it all. That's what NASA has stated based on the IPCC data and their own data. And we do need to look at taking some sort of action. So, what is the impact of climate change in the Gulf of Maine? And I found this article. This was produced by Scott Krause at the New England Aquarium. And he mentioned how, this is where we have the nice the cool Nova Scotia current coming down, bringing in, and then the Labrador current there at the top there, bringing this nice, cold, rich, oxygenated water onto the coast of Maine, which is great for phytoplankton growth and things like that. There's a concern about what will happen when we have more fresh water coming up into the northern Atlantic from the glacial melt in Greenland, because it could affect the food chain and the phytoplankton in the Gulf of Maine. This is what normally occurs in the winter, the spring, and summer. The red shows the phytoplankton blooms and where there's most phytoplankton. And so they're worried about just how much will be there and how much will be diminished by the difference in salinity of the water or the increased, more cold water. What can happen if that does get a lot colder than what it is right now? And the thing is that they're saying that, the copepods could decrease in number, and they are the food source for the basking char, herring, and the right whale that live off the coast of Maine at various times in the year. If the herring population decreased, then the bluefin tuna, the cod, the humpback will also be impacted through the food web. So there's some concerns for the fishing industry, because I know from my colleague who was 8th, 6th generation fisherman out of Booth Bay, he's not a fisherman anymore because the number of days he could have at fish becomes lower and lower. And when it reached about 80 something, 85 or 80, he sold his boat. He bought himself a catamaran, 60-odd foot catamaran. And now what he does, he spends the winter in the Caribbean doing sightseeing tours for guests, and in the summers now here, he's out of Sag Harbor, and he takes people out on, sunrise and sunset cruises. He's making more money doing that than he did as a commercial fisherman, which is kind of sad, because fishing has been, the lifeblood of many people from Maine for many generations. They're also seeing an increase in the diseased lobsters. Red tides are going to become more abundant, and maybe other diseases like giardia could be more prevalent in New England. And this is a climate change book that I found, which directly relates to Maine. It's actually on display. If you go over to the, what's it called, the Surdemont, thank you. My French isn't that good. The Surdemont over on Mount Desert Island. It's actually in there in the climate change exhibit, which I thought, oh, that's cool, because I wanted to end by talking to you about some things about Maine in particular. And this data I got from that research. So here it just shows you that the annual temperature is increasing. It's increased 3 degrees since 1895. That's the present, and I think that's the future. This is the change in the temperature that Maine is going to see. It could be anywhere from 3 to 5 to 5.5 degrees Fahrenheit, to 2050. The actual warm season has expanded already by 2 weeks, and they think by 2050, around there, it's going to be up to 36 weeks. It's going to expand and elongate another 2 weeks. The number of heat index days is predicted to be increased from, say, in Augusta, 3. That's a heat index of over 95 degrees. They usually have about 3, and they're going to get about 11 around 2050. And in Bangor, it's about 3. It's going to go to about 10. So that's something else that's going to be apparent according to the research. Here's the Lyme disease data. In 2001, there was 108 cases. In 2013, there was 1,377 cases. So Lyme disease is an increase in Maine. There's going to be changes to the maple syrup industry as a result of the warmer temperatures. This is from that study. They say that about 2/3 of Maine's plants and animals are vulnerable to the climate change that can occur. And also that the increase in invasive species will go up as a result of climate change. You might know what the winter moth is. I don't, but obviously it's regarded as a pest around here. This is the precipitation, which is going to increase, and it has done 6 inches since 1895, and it's going to continue to increase. Again, that same sort of graph, that's what you got now. This is what you could have by 2050-ish, and the increased precipitation could be anywhere from more, this is 1 to 2 inches more, or some places could have 6 to 7 inches more rain over the next 30 years or so. And these are what they call the extreme precipitation events, where you're having like 4 to 5 inches of rain in one rainfall, or in, overnight, or in 24 hours, or whatever it is that they get measured it by. Look at Bar Harbor here. It's gone up, and it's increasing. So we're seeing pretty much all over, except for the northern part. You're seeing these increased, well, the inland Lewiston's not got as much there, but a lot of other places. They're saying when you have these big rain events, there's going to be more rain falling in those. This is the snowfall decreasing. I don't know if some of you are noticing that, but this is the decrease. It's decreased, let's say, overall an average of 1 inch since 1895. This is what they think is going to happen by about 2050. The coastal areas are going to decrease by over 40% of the snowfall that they're getting today. Moving inland, you're going to have 20 to 40% less, and up in the further inland, it's going to decrease by less than 20%. The sea surface temperature, again, increasing, and there's some ranges. What it could be if it's maximum, or this is really the expected range there. So these are some of the things that are going to be observed in Maine as a result of climate change. That's a fungus that's going to affect trees. Friends of mine that live here tell me that their towns have had to spend lots of money on road surfaces that got washed out. With the winter recreation, skiing could be affected. Also snowmobiling could be affected. The farming future, even though the warm season's extended, what happens when all that rain comes, and how is that going to affect it? People are, the jury's still out on that. I remember when I was up here in 2012, lobster prices, what the lobstermen were getting was just over $1.25 for a lobster or something, was reported in the news. Of course, if you ate out at a restaurant, they didn't, that price was not reflected in what you were paying for them in the restaurant, of course. But this was an interesting fact that I ascertained from that report, that they said the center of the lobster harvest, as a result of the changes in the sea temperatures, has now moved from Casco Bay to down east Maine. And again, I don't know if that's something that you are aware of or have noticed, but this is what's come out of the report. And you're going to see a lot more new species showing up in the fishermen's nets, and you're going to see a decrease in others. Particularly salmon was highlighted in that report. Because the sea and the water is getting more acidic, the clammers have actually, in some areas, sort of taken a very proactive step. They have taken crushed shells and put them out on the clam flats in order to act as a buffer against the increase in hydrogen ion concentration in the sea. There's a sea level rise from Portland. Again, steady increase. And these are some of the things that could or are happening. And this here, I understand, is a bit of a political thing going on right now, where people are wanting to have their houses reassessed because the government or the town communities, councils or whatever they are, that are telling them, hey, now you're in the flood zone. You know, particularly Rockland. I have a friend of mine lives down there. You know, in Rockland, there's a big controversy about that because what happens is their insurance costs are rising, and that's as a result of their zoning. So I was at Acadia, and I just mentioned these sort of things, and I just want to go through this pretty quickly, because I know we're coming to the end. I want to come to the end and not keep you much longer. I appreciate your being here, and just wanted to finish off with a few things about Maine. So this is what the park rangers, they tell me, have done through the duct tape in their ankles. Some of them, when they're out doing stuff in infected areas, so that they limit their Lyme disease. They're seeing a shrub has been replacing native plants. And there are other things that are coming in, invasives. And some of the other natives are disappearing. It could be as much as 30% of the wildflowers that have actually declined. Some disappeared. Some research. I got this from the Boston Globe article, about, I think it came out about a year or so ago. Already mentioned this, about how the trees are going to change in New England, and the hickories and the oak pines are going to come in and replace them. The Maine state bird is going to decrease as it travels further north. And because they've got more precipitation, there's a lot more erosion, and that's really hitting the budget to help repair the erosion that's going on. A lot more washouts. Mentioned about how rising seas can affect salt marshes. This young lady did a PhD on this, and she again found shrubs that were sensitive to temperature. They're blooming earlier, and then what happens is that when they bloom earlier, they're not in sync with maybe the bees that pollinate them, or they're not in sync with the birds that come back and migrate through the area. So they've got no food. And they're obviously up at Cadillac Mountain. She found out that there are plants up there that are blooming a lot earlier than normal. So, you know, we are seeing changes. I hope changes in the air. I hope it's a good change. You know, we're actually looking at some of these and seeing how effective they are. As I mentioned earlier, we've got to go. I'm trying to get my students to think a lot differently, so that when they get out, they have the skill set to be creative and have good problem solving and critical thinking skills, because that is very true. And the US Climate Action Partnership is totally on board, and again, it's going to add to the US economy as opposed to it being a risk for the US economy. There's a couple more things I want to show, just this one here. And
we have a situation brewing with the carbon dioxide.
We had a CO2.
you may have seen this movie. It's Apollo 13. It's one of the great scenes in Apollo 13.
So I told the doctor.
You're already up to 8 on the gauges. Anything over 15 and you get...
They're finding out that in the spacecraft,
beginnings of brain
CO2 levels are rising.
Command module. They take square cartridges.
The ones on the limb are round.
Tell me this isn't a government operation.
You know, it's one thing after another. If you've seen that film,
What we looked at.
you know, I read the book.
2 levels are going to be getting toxic.
Well, I suggest you gentlemen invent a way to put a square peg in a round hole. Rapidly.
Okay, people, listen up. People upstairs handed us this one, and we gotta come through. We gotta find a way to make this fit into the hole for this, using nothing but that. Let's get it organized.
Okay, let's build a filter.
Better get some coffee going, too.
I believe that we can do the same for this planet as these guys did for those astronauts. I really do. And I've always said this sort of thing to my kids. It's about asking the right questions. It's not so much, if they answer my question correctly. It's if they can come up and ask questions like that. How can we fit that square CO2 filter into this round hole? And I know that we're educating young people today that can face these challenges, and I really believe can take it to a different level where I hope we can get the level down. Here are some of those types of questions. This was one of the gentlemen in the IPCC that stated those. And this is, I posed a question to my students that I said to them, design an experiment that can demonstrate the greenhouse effect and at the same time can show that carbon dioxide absorbs heat, increases the temperature of the air. And I didn't give them any more information than that. And they got into groups and they come up with lots of different types of experiments. I knew some of them wouldn't work, but it's not for me to tell them it won't work because they would have lost that part of the educational process. They've got to find it out for themselves. As a research scientist, I didn't know if my experiment would work or not. And if it gave me different results than I was expecting, you have to say, wow, that was interesting. And it made you think and eventually get to the experiment that did give you the result or the idea that, or maybe you changed your idea. So what they did here, eventually, this was the one that they were never, it was like the light bulbs were going off at that time. They had clear plastic 2-liter soda bottles. They had 4 of them. We did 3 on this experiment. We had one, in each one we put 100 milliliters of water. And there's a thermometer in the top. And this one, we just left as 100 milliliters of water. This one, we added some potassium hydroxide to it, which would decrease the amount of CO2. This one, they added a quarter of an Alka-Seltzer tablet, which increased the amount of CO2. This is a thermometer just laid on the desk. And we put on heat lamps in the 4 corners. And what they saw was the bottle with the increased CO2, and look at that, that's a temperature change in degrees. And then there's the ambient one, and there's the one with less CO2. And I think that was a really cool experiment that they designed that themselves. So there's the change in ice. This is another good one about the Maldives, and this is one about the Canary Islands that are suffering from sea level rise, and they're trying to relocate. If you want to see more articles, there's lots of them around on the internet. I would suggest you check out your own carbon footprint, see what it is, and see if you can minimize it. Even if you do a lot of good things environmentally. I was surprised how high my carbon footprint was. And there's a few things that you can do. I'm sure you know a lot of these. Fuel efficient cars, insulation, weather stripping, incandescent lights. Everything's going online now. It's saving paper. It's pretty good. This is what communities are doing. Community gardens I know of. Community carpooling. They're planting trees. Looking at the public transportation system. And your energy, your electric, your utility company will provide, hopefully, I know most of them do, free home energy audits. And this was a little fun thing that some kids put together of all the different things that you can do, public transport. So this is what I've been saying to my students for many years. No one can do everything, but everybody can do something. So what are you going to do? And I want to leave you with this quote from Bill McKibben. So, So thank you very much. I know it was a fairly lengthy presentation, but I hope that you have increased your climate science literacy tonight by a notch or two.
Dean, I want to thank you. And you mentioned that you'll bring some of your books outside.
Yeah,
We've
my
got
daughter's
some
out there.
Refreshments out there, some cookies, some coffee. In the interest of giving folks a chance to go ahead and stand up, I wonder if we could take some informal questions out of the
Sure,
audience.
certainly.
Okay.
No problem at all.
Let's do that then. So thank you, everybody. And also want to mention a lot of the research that you referred to at the end around the park is a lot of the kind of work that Schoodic Institute is involved in. Nick Fisicelli is here tonight. He's our new Forest Ecology Program Director. The researcher you mentioned, Caitlin McKenzie, is on a small fellowship from Schoodic Institute this summer, wrapping up some of her work. And these are the kinds of questions that we're very much interested in refining our understanding of and helping to make communication connections with the park and with the public, with our students. So we'll wrap up there. Thank you.
Thank you.